So for this one, for x of n, okay, now I was writing the unilateral Z transform for this one, x of n minus 1. For this we have Z transform as x of z plus x of minus 1 z to the power 0 plus x of z to the power minus 1 x of, let me write it properly, x of z to the power minus 1. So x of n idre, this is your Z transform, x of n minus 1 idre into, that is x of minus 1 z to the power 0 andre 1 barutalva. So x of minus 1 plus x of z inverse. Okay, so let us generalize this. I have given with respect to problem. Now consider in unilateral Z transform, first one, if you have x of n, given is x of n, the Z transform is x of z. Given is x of n minus 1, then Z transform is x of minus 1 plus z inverse x of z. Okay, similarly x of n minus 2, Z transform is x of minus 2 plus x of minus 1 z to the power minus 1 plus z to the power minus 2 into x of z. Okay, this is what we are going to get. Then if I say x of n minus 3, Z transform would be x of minus 3 plus x of minus 2 to the power into z to the power minus 2 plus x of minus 1 to the power z to the power minus 3, minus 1 plus z to the power minus 3 x of z. Same is true with y of n minus 1, y of n minus 2 and all. Is that clear? Now let us move on to the problems part. In unilateral Z transforms, as I have explained, we are going to deal with the initial conditions. Okay, we need to deal with the initial conditions. So here you can see, solve the following linear constant coefficient difference equation. The name is given as constant coefficient difference equation using Z transform method. So this is the difference equation given. Okay, this is the difference equation given with initial conditions as y of minus 1 equal to 4 and y of minus 2 equal to 10. So this is a problem on unilateral Z transform. So normal Z transform, y of n minus 1 will be written as z inverse y of z. But for unilateral, y of n minus 1 is written as what? Y of minus 1 plus z inverse y of z. You can see in this problem here. This is y of n minus 1, Z transform of y of n minus 1. This is Z transform of y of n minus 2. Okay, so this is how we are going to deal with the Z transform now onwards. So let us read the question again. We have to solve the difference equation having initial conditions y of 1 is equal to 4 and y of minus 2 is equal to 10. So solving this equation means what? Using Z transform, we need to write it in this sequence form. Okay, we have been given it in the form of difference equation. We need to form an output equation in the sequence, that is output sequence form. Okay, so let us go through the problem now. Y of n minus 3 by 2 y of n minus 1 plus 1 by 2 y of n minus 2. Problem number 1 is y of n minus 3 by 2 y of n minus 1 plus 1 by 2 y of n minus 2 equal to 1 by 4 to the power n u of n with initial conditions y of minus 1 and y of minus 2 given. Okay, so it is 4 and 10. For this, we need to find out y of n in terms of what? In terms of the sequence. This is a different equation. We need to find out y of n sequence. Okay, so using the Z transforms, unilateral Z transform to be specific, since initial conditions are given, we need to use unilateral Z transforms. For that, y of z, y of n is transformed into y of z. Okay, similarly here minus 3 by 2. For this one, z transform is y of minus 1 plus z inverse y of z plus 1 by 2, as it is. Z transform of this one is y of minus 2 plus y of minus 1 into z inverse. Carefully observe this. When this comes, y of minus 2 is a constant. You are not multiplying anything here. It is z to the power 0 multiplication with. Then z to the power minus 1. Then z to the power minus 2. Z to the power minus 2 y of z. Okay. Earlier, again and again I am explaining this because you need to remember this. Whenever initial conditions are given, this is the method. Earlier we were not considering these values, minus 2 and minus 1. This was assumed to be 0. Okay, we are considering for y of n minus 2 only this one, y of n minus 1 only this one, because initial conditions were 0. Now initial conditions are given, we need to put that and solve the problem. Okay, so now continue with the given question. Equal to 1 by 4n u of n. For this, what we'll get as the transform 1 divided by 1 minus 1 by 4 z inverse. Correct? This is the z transform of this sequence. Now, what is y of minus 1? It is 4. What is y of minus 2? It is 10. So substituting that, y of z minus 3 by 2, y of minus 1 is 4 plus z inverse into y of z plus 1 by 2, y of minus 2 is 10 plus y of minus 1 is 4, z inverse plus z to the power minus 2 y of z equal to 1 divided by 1 minus 1 by 4 z inverse. Okay. Now separating out the terms, y of z I take common, means 1 minus 3 by 2 Z inverse plus 1 by 2 Z to the power minus 2 minus 3 by 2 into 4, that is 2 and 2 will cancel out. What we'll get is 3 into 2, 6 minus 6 plus 1 by 2 into 4 Z inverse plus 1 by 2 into 10 is 5. Okay, so this is what we'll get, minus 6 and plus 5. Minus 6 and plus 5 is minus 1. So we can directly write minus 1 plus 1 by 2 into 4, that is, it is 2Z inverse 1 by 2 into 4 is plus 4, 2Z inverse equal to 1 divided by 1 minus 4, 1 by 4 Z inverse. This term remains same, 1 minus 3 by 2 Z inverse plus 1 by 2 Z inverse square of y of z. So if I want y of z, then it will become 1 divided by 1 minus 1 by 4 z inverse plus 1 minus 2 z inverse. Okay, divided by this whole term, 1 minus 3 by 2 z inverse plus 1 by 2 z inverse square. Okay, so this is what we are going to get. After that, we have to cross multiply and simplify the y of z equation, which is similar to what we have done earlier. Correct? This is what we have got now. Till here, it is same. So, give me a second. Yes, this is what we get after simplification. When we multiply here and simplify it, we will get 2 minus 9 by 4 plus 1 by 2 z inverse square. This will be 2 minus 9 by 4 z inverse plus 1 by 2 z inverse square divided by 1 minus 3 by 2 z inverse, 1 minus 3 by 2 z inverse plus 1 by 2 z inverse square multiplied by 1 minus 1 by 4 z inverse. So this will not change, this remains same. Okay, only this part. So you can clearly see here how many zeros are there, z inverse and z inverse to the power minus 2. So n is equal to 2, number of zeros. M is equal to here 1, 2 and 3. There are 3 poles. So obviously n equal to 3, m is equal to n is equal to 2, m is equal to 3, n is lesser than m. You can apply partial fractions. No need to go for long division and then partial fractions. Directly you can apply the partial fractions because n is less than m. If n is equal to m or greater than, then one step of long division and then partial fractions. Okay, so first you need to find out, for that you have to find out the roots of this. Correct? 1 minus 1 by 4 z inverse is correct. No need to consider this one. Only for this there are 2 roots of z that you have to find out and then write it. So the roots what we get is 1 minus z inverse and 1 minus 1 by 2 z inverse. That means z is equal to 1 and z is equal to 1 by 2 are the roots. When you calculate it using the ax square plus bx plus c rule. Okay, so 1 minus z inverse 1 minus 1 by 2 z inverse, 1 minus 1 by 4 z inverse. These are the roots what we have. Okay, this is y of z. I hope you have understood till here, because after this part you know how to solve it using the partial fractions directly. So a1, a2 and a3. Value of a1 is 2 by 3, a2 is 1 and a3 is 1 by 3. So using partial fractions, y of z will be using partial fractions. What do we get? 2 by 3 divided by 1 minus z inverse plus 1 divided by 1 minus 1 by 2 z inverse plus 1 by 3 1 minus 1 by 4 z inverse. Using partial fractions you can solve for a1, a2, a3 and you will get this as your answer. Now simply you need to apply the inverse z transform. What is the rule? 1 divided by 1 minus a z inverse will have inverse z transform as a to the power n u of n. Okay, if system is causal. Otherwise u of minus n minus 1 would be the answer. Minus, everywhere you will have to put minus. So y of n will be 2 by 3. Here in case of this one, a ಬದಲಿಗೆ ಏನಿದೆ 1 ಅಂತ ಇದೆ. So 1 to the power n. If you don't write also it is fine, but better to write this 1 to the power n. Okay, answer will be same. Plus 1 by 2 to the power n u of n. Why 1 by 2? In the place of a we have 1 by 2 here. Okay, similarly 1 by 3 into 1 by 3 into 1 by 4 to the power n u of n. So this is the output y of n with initial conditions y of minus 1 is equal to 4 and y of minus 2 is equal to 10. Okay, so this is how you are going to solve the problems using the initial conditions. Only thing, how to apply the z transforms you must know for the difference equation. If this question is asked, it will be asked for 8 or 10 marks. So definitely one question will be there on this topic in the z transform. Okay, so now let us go through the next problem. Briefly I will let you know what is that problem. So you can clearly see here 2 by 3 into 2 by 3 into u of n, that is 1 to the power n we have not used here, but if you use also same answer you will get. This is 1 by 2 to the power n, 1 by 4 to the power n. N is greater than 0, so no need to mention because u of n is already there. So this is first problem. Next problem is similar to this. You can see here, find the natural response. Simply you need to remember what is natural response. Natural response means, please make a note of it, what is natural response. Second problem is on natural response. Natural response means when input is 0, input is equal to 0. That means x of n is equal to 0, x of n minus 1 is equal to 0, and whatever the input terms, difference terms are there, they are all equal to 0. Okay, that is natural response. And another term I have told you is forced response. Forced response anta heli question alli idre eno, it means that initial conditions are 0. Initial conditions equal to 0. Okay, remember this. Y of 1 minus 1 minus 2 ಅಂತ ಎಲ್ಲ ಏನಾದರೂ ಕೊಟ್ಟಿಲ್ಲ ಅಂತಂದ್ರೆ then they might have mentioned forced response anta. That means what? You have to consider the equation, but you have to substitute y of minus 1, y of minus 2 equal to 0, x of minus 1, x of minus 2, all these initial conditions as equal to 0. So this is what we were dealing in the previous few problems, not the immediate previous problem, but day before yesterday, and when we started with inverse Z transform, we are dealing with forced response only, considering y of minus 1, y of minus 2 and all other initial conditions as 0. So remember these 2 points. Natural response ಅಂದ್ರೆ ಇನ್ಪುಟ್ ಎಕ್ಸ್ ಆಫ್ ಎನ್ ಕೊಟ್ಟಿದ್ರು ಅದನ್ನ ಈಕ್ವಲ್ ಟು 0 ಅಂತ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕು. ಫೋರ್ಸ್ಡ್ ರೆಸ್ಪಾನ್ಸ್ ಅಂದ್ರೆ y ಆಫ್ ಮೈನಸ್ 1 ಯಾವುದೇ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ರು ಅದನ್ನ 0 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ಓಕೆ, ಬೇರೆ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ರೆ ಇವಾಗ 4 ಅಂತ ಕೊಟ್ಟಿರ್ಬೋದು, 5 ಅಂತ ಕೊಟ್ಟಿರ್ಬೋದು. ಇಫ್ ಇಟ್ ಈಸ್ ಫೋರ್ಸ್ಡ್ ರೆಸ್ಪಾನ್ಸ್, ದೆನ್ those initial conditions are not valid. They are equal to 0. Okay, so in this question, find the natural response of the system described by the difference equation. So this is the difference equation and we need to find out the natural response. We know that natural response is response due to initial conditions only. So natural response, it is because of initial conditions. That's why we have made input as 0. Input 0 ಮಾಡಿರೋದಕ್ಕೆ ಏನು ಕಾರಣ ಅಂದ್ರೆ natural response it is based on only initial conditions. Andre y of minus 1, y of minus 2 are responsible for the output, not input x of n or x of n minus 1. So directly we can rewrite the equation. ಈ ಕೊಟ್ಟಿರೋ equation is similar to previous one, right? So 1/4 1/8 ಅಂತ ಇದೆ, ಅಷ್ಟೇ ಡಿಫರೆನ್ಸ್. So we can rewrite the equation like this: y of n 1 minus 1/4 y of n minus 1 minus 1/8 y of n minus 2 equal to 0. Earlier here it was x of n plus x of n minus 1. ಈ ಎರಡು ಟರ್ಮು ಈಕ್ವಲ್ ಟು 0 ಆಗಿದೆ. ಯಾಕಂದ್ರೆ ನ್ಯಾಚುರಲ್ ರೆಸ್ಪಾನ್ಸ್ ಅಲ್ಲಿ ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ಸ್ ಪ್ಲೇ ವೈಟಲ್ ರೋಲ್, ವೆರಾಸ್ ಇನ್ಪುಟ್ ಈಸ್ ನಾಟ್ ಹ್ಯಾವಿಂಗ್ ಎನಿ ರೋಲ್. ಇನ್ಪುಟ್ 0 ಅಂತ ಕನ್ಸಿಡರ್ ಆಗುತ್ತೆ ಅದಕ್ಕೆ. ಸೊ ನಾವು ಟೇಕಿಂಗ್ ಯುನಿಲ್ಯಾಟ್ರಲ್ Z transform, y of n Z transform is y of z, y of n minus 1 Z transform is y of minus 1 Z inverse y of z, y of n minus 2 Z transform is y of minus 2 plus y of minus 1 Z inverse plus Z inverse square y of z equal to 0. Okay, but y of minus 1 ಅಂತ 1 ಅಂದ್ರೆ ಏನಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ ಅಲ್ಲಿ 0 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So you have to substitute y of minus 1 and minus 2 now. Y of minus 1 is 0, y of minus 2 is 1. After substituting, you will get answer as now you can see, after substituting you will get this as 1/4 Z inverse minus 1/8 Z inverse square minus 1/4 to the into y of minus 1 will be 0 because this value is 0. This value is 0. Again here it is 0. So after substituting you will get minus 1/8 here into y of 1, into 1. So it will be, if you take this on the other side, it will become 1/8 divided by this term. Okay, so we will get final answer as this one. Now you know how to go with the partial fractions. 1 minus 1/4 Z inverse minus 1/8 Z inverse square is splitted as 1 minus 1/2 Z inverse 1 plus 1/4 Z inverse. For this a1 and a2 we need to calculate. that is shown here, and it would be 1 by 12 and 1 by 24, and final y of n will be this one, 1 by 12 into 1 by 2 to the power n u of n, 1 by 24, 1 by minus 1 by 4, because here it is plus, so we'll get minus 1 by 4 to the power n u of n. This is 1 by 24. Similarly, here we have 1 by 12, 1 by 2 to the power n u of n, after taking the inverse Z transform. Okay, this is the answer you are going to get, which is given here. Similarly, the next problem we have is, if the input is given and we are asked to get the forced response, andre forced response y of minus 1 equal to 0, y of minus 2 equal to 0 substitute ಮಾಡಿಬಿಟ್ಟು ಈ ರೆಸ್ಪಾನ್ಸ್ ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು, which is similar to our earlier Z transform. This is the easiest problem which you can solve on your own. Okay, so tomorrow we will solve another two problems, that is problem number 9 and 10, and that will complete your Z transform syllabus. Is that clear?